Hello dear students, welcome to YouTube channel. So today we have to discuss chapter number 5, that is laws of motion. So in previous class we have already discussed about the motion in a straight line, that is rest and motion, and without knowing the cause for the motion we have derived number of equations like v equal to v naught plus at, x equal to v naught a plus half at square, and as well as v square equal to v naught square plus 2 ax. And also we have discussed a freely falling body and the motion under the influence of gravity, motion in a straight line, and also motion in a plane also we have discussed. Suppose the object is thrown not vertically or not horizontally, so it will move some certain angle of projection. So then we are getting the number of equations. So that is the equation for projectile motion, and height, time of flight, and range of the projectile we have already discussed by knowing about the vector. And also uniform circular motion we have already discussed, means any object which is moving along a circular path with constant speed. So speed is constant but continuously its direction is changing, and we are getting the acceleration, and the acceleration is square of the magnitude of the speed divided by radius, that is a equal to v square by r. Okay, so now we have to discuss the laws of motion. See, as per the syllabus, okay, in Newton's first law, second law and third laws are not necessary to discuss, but it is a basic one, and which is very essential also. Okay, the concept of rest and motion we have already discussed. Okay, a state of rest or uniform motion along a straight line continues to be in the same state unless it is compelled to change that state by an external agent called force. So simply force means it is an external agent or agency that will changes or tends to change either direction or the magnitude of the motion. Clear? Or both, and that one is called as the force. Okay, then come to the term momentum. Simply the momentum means quantity of motion, how much it is moving. Okay, it is moving with velocity v, we can say in previous chapter, but how much it is moving means the quantity of motion. So quantity we can express it in terms of mass, so hence how much mass is moving, that one is the momentum. And simply the momentum of a body is defined as the quantity of motion associated with the body, and it is given by the product of mass of the body, that is m, and its velocity v. It is denoted by p. P is the symbol used to denote the momentum. It is also ability of a body to impact or to impart motion to another body. So suppose the massive object which is collide with or impact with another body, so that body also starts moving or motion. So what it means, the momentum that will be transferred from one body to another body. So simply momentum means mass into velocity, and it is a vector quantity, remember. Okay, vectorically vector p equal to m times vector v we can write. So and its SI unit is kg, meter per second. Okay, kg is the unit of mass, meter per second is the unit of velocity. Clear? So this is about the momentum, and clearly its dimension is m, and dimension of v is lt minus 1. So hence the dimensional formula of momentum is mlt minus 1. Cleared? Okay. So now come to the law of conservation of momentum. The law of conservation of momentum. In previous also, I think all of you studied about the law of conservation of energy, that is, energy cannot be created nor destroyed. In the same way, the law of conservation of momentum also. According to the law of conservation of momentum, momentum can neither be created nor destroyed. Okay, means it can transfer from one body to another body, but it is not possible to destroy the momentum, remember. So in closed system consisting of number of bodies colliding with one another, the total momentum of the system remains constant, that is conserved. That is conserved. Cleared? Okay. So according to the law of conservation of momentum, the total initial momentum of the system equal to the total final momentum of the system. See, suppose there are two bodies, let you can say m1 and m2, are their masses are moving with the speed v1 and v2, that you can say in the same direction. Suppose one body is collide with another one. Okay, so then what happens? The mass remains same, m1 and m2, but what happens? Their individual speeds are changes. So whatever may be the momentum of two bodies before collision and the total momentum after collision, both are same. Is it clear? Suppose the initial velocities of m1 and m2 are u1 and u2, and after collision its velocities are v1 and v2, then we can say m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Is it clear? So it means there is no profit or loss of momentum. Okay, so there is no gain or loss of momentum, hence the law is conservation of momentum, that is momentum is conserved, means not losing the momentum or not creating the momentum. Cleared? Okay, we go to the next point. Note down this point. Consider two bodies of mass. Okay, consider two bodies. Okay, among two, first body you can say body A having the mass m1 and moving with velocity v1, and similarly another one is you can call it as B, and which one is moving with velocity u2, its mass is m2. Okay, along the same direction. Okay, then the momentum of a body, okay, just we have already discussed. Okay, see, in this consider a body A of mass m1, B of mass m2. Okay, see the first figure. Okay, in this first figure, okay, see, so here u1 and u2 are the velocities, and during the collision A is collide with B. After collision A and B are moving in the same direction with velocity v1 and v2. Okay, so in last figure you have to make it as v2 because it is typed as v1 only, but velocity of the B is v2, make it as v2. Okay, see here, see the initial momentum of A is m1 u1, final momentum of A is m1 v1. Change in momentum of A in t second is m1 v1 minus m1 u1. Rate of change of momentum is m1 bracket v1 or m1 v1 minus m1 u1 upon t. Okay, I think already all of you know, according to Newton's second law, the rate of change of momentum is directly proportional to the force impressed on it, and Newton's third law, action and reactions are equal and opposite. Okay, so similarly for second bodies, the velocities are changing as u2 to v2, okay, in the same interval of time or same time. So the initial momentum of B is m2 u2, final momentum of B is m2 v2. Change in momentum of B in t second is m2 v2 minus m2 u2. Rate of change of momentum of B is, let we can say that force is F2 equal to m2 v2 minus m2 u2 upon t. This is the force exerted by B on A. Okay, see now here this force F1 equal to F2, but the directions are opposite, because if A is collide with B, the force exerted by A on B is opposite direction. So from that we can write m1 v1 minus m1 u1 by t equal to m2 v2 minus m2 u2 divided by t, make it as bracket. So now tt get cancel, m1 v1 minus m1 u1 equal to minus m2 v2, minus of minus becomes plus m2 u2. So now you have to take m1 u1 m2 u2 one side, m1 v1 and m2 v2 another side. So we'll get m1 v1 plus m2 u2 equal to m1 v1 plus m2 v2. See, so this, from this expression it is clear that the total initial momentum of the system before collision and the total final momentum, means after collision, are same. So this proves the law of conservation of momentum. So it means whatever may be the total momentum before collision and after collision, the total momentum remains same. So this is the law of conservation of momentum. Law of conservation of momentum. Note down this. Okay, write the notes properly. Okay, see this one is repeated momentum because we have already given in the previous slide also. Okay, so this part is Cleared? So note down up to the law of conservation of momentum. Cleared? Okay. So in next class we have to discuss the equilibrium of a particle. The equilibrium of a particle. Cleared? Okay. Thank you.